guys, welcome back to another Kubernetes video. Today I will be continuing the series on Kubernetes security and specifically talking about service accounts. So first of all, what is a service account? Well, it provides an identity to non-human users in our Kubernetes cluster. So if we're a human user, we'll be down here with our kubectl client and we'll have a user account that will be associated with any requests that we send to the Kubernetes API. Similarly, if we have a process running in a pod that needs to have access to the Kubernetes API, that process will have a service account associated. So a service account is actually a Kubernetes API object. You can query the Kubernetes API using something like kubectl get service accounts. However, you can't do that with user accounts, so they are managed slightly differently, but that's just something to be aware of. We can create and delete Kubernetes service accounts, but it doesn't work exactly like that for user accounts, but we'll get onto how exactly user accounts are managed in future videos. So each service account will have an associated token, and this is what will be used to actually authenticate against the Kubernetes API. Now, when a pod is created, a pod will be associated with the default service account if we do not specify a service account. This is done via a projected volume, and what a projected volume is essentially just a volume that has multiple sources. Those sources are mapped to one directory in the pod. So, as I mentioned, the default service account is also given minimal permissions, and this is really just a security best practice. For any scenario, we want to follow the principle of least privilege. And this is really just a security best practice for any security scenario. We want to follow the principle of least privilege to essentially give enough permissions for the user or the process to do what they need to do, but no more than that. So let's have a closer look at the individual fields of this projected volume that's added for a default service account, or really for any service account. The first one is the ServiceAccount token, and this is what is used to authenticate against the Kubernetes API. It is generated from the Kube API, but Kubelet is the one that generates it, and then Kubelet passes it on to the pod, and that process is done via a token request, which is an API that the API server exposes that allows us to retrieve tokens. Next is the config map component, and this contains a CA cert, and what that CA cert allows us to do is to ensure that we're actually talking to the API server. So this is a CA for the API server itself. Finally, we need to know the namespace that the token exists in, and that is done via this downward API. And what the downward API allows us to do is just reference other fields within a Kubernetes object. So as you can see here, the field path is metadata.namespace, and that's what we're going to use. It's essentially the namespace that we've already defined for this pod. Now, there are a few components within Kubernetes that allow us to manage service accounts more easily. So when we set up a service account, there will be tokens associated with that. There will be volumes that need to get mounted to pods, and all of this work that's associated with setting up service accounts. So there are a couple of components that make the management of all of this easier. The first one is the token controller, which is part of Kube Controller Manager. So a few of the functions that the token controller has are to watch for service account deletion and delete the corresponding token secrets. So if we have a service account deleted, we obviously don't want to have the secrets associated with that service account, for example, the tokens, to be hanging in our Kubernetes etcd storage essentially. It also watches for token addition and ensures the referenced service account exists. And it watches for secret deletion and removes a reference from the service account if needed. So if a service account references a secret and that secret is deleted, we need to remove the reference. The next component that helps with Kubernetes service account management is the service account admission controller. Now, admission controllers are part of the Kube API server that either validate incoming requests or mutate them. In the case of the service account admission controller, this is a mutating admission controller in that it modifies pods as they are created. So if no service account is specified, it sets to the default service account. As we mentioned, every namespace will have a default service account. If a pod does not have a manually specified service account, the default service account will become that pod's service account. And this is done via the admission controller. It ensures that specified service accounts exist when we create a pod. It adds an extra volume that contains a token for API access, and it adds a volume to each container in the pod. And this is part of what is done by the admission controller. So we can see we set the service account to default, service account name to default, and then under volume mounts, we specify the mount path and then the name of the volume that we're going to mount. So in this case, Kube API access actually refers to this volume that we specified earlier. If this is a default service count, all of these fields are actually added to the pod definition by the admission controller. So that is the video on service accounts. I hope that was useful for you. If you have any questions, please do leave a comment. Please like and subscribe, and I'll talk to you in the next video.